Happy morning, guys. Today we shall see the problems related to Nernst equation, application of Nernst equations, and the relation between cell potential and Gibbs free energy. Right. For a reduction reaction, the Nernst equation is E cell that is equal to E naught cell minus 2.303 RT by NF log of 1 by Mn plus. That is the concentration of the reactant. If it is a metal, the concentration is unity. That's why we have taken as 1 here. That is, if we substituting all the variables here, it will be 0.0591 by N. Right? So E cell is equal to E naught cell minus 0.059 by N. N is the number of electrons log of 1 by Mn plus. This is the equation you have to take in the case of reduction. Right. And to calculate the electrode potential of the cell, if the equation is given like this, we should modify the equation accordingly. That is E cell is equal to E naught cell minus 0.0591 by N log of concentration of the products raised to the power of its coefficient by concentration of the reactants raised to the power of its coefficient, right? And for equilibrium constant, to calculate equilibrium constant or E naught cell, either one value will be given, either E naught cell value will be given or Kc value will be given. E naught cell is equal to minus 0.0591 by N log of Kc at 298 Kelvin. And cell potential and Gibbs free energy. Del G naught is equal to standard free energy is equal to minus NF E naught cell, and del G naught is equal to minus 2.3 RT log of Kc. If Kc is given, we can calculate the del G naught. If del G naught is given, we can calculate the Kc. Right. Like that, if del G naught is given, we can calculate the E cell. If E naught cell is given, we can calculate the del G naught. Let's go for the problems here. Yes, calculate the del R G naught for the equation. Just now we had seen a del R G naught is equal to minus NFE. If you apply that formula, we can calculate the del R G naught. So this is the solution here. E naught cell is equal to minus 2.7 they had given. Reaction they had given. So N is equal to 2, del R G is equal to what? So del R G naught is equal to minus NFE. So minus 2 into N minus 2 N. That is F under the Faraday. And then into 2.71. E naught value they had given. So the final value will be 5 to 3.03. That's the first thing. Next, equilibrium constant Kc has been given 10. Then calculate the E naught cell. Right, the relation between Kc and the E naught cell. E naught cell is equal to 0.0591 by log Kc. So they had given the Kc value. So here we have to substitute 10, and the number of electrons involved here is 2. So E naught cell is equal to 0.0591 by 2 log of 10. So the value will be 0.295. Just mere substitution is enough here. Then the standard electrode potential E naught for the Daniell cell is given as plus 1.1 V. Calculate the del G. Gibbs free energy for the reaction. Right? Faraday value we know that already they had given. So as usual, we have to substitute in the formula. Here the number of electrons, 2 electrons. The number of electrons involved in the reaction, 2 electrons. So 2 electrons in E naught cell has been given. So del RG is equal to minus NFE. So minus 2 into 1.1 into 96500. That is equal to minus 213 kilojoule per mole. The answer is joule per mole. So we had converted into kilojoule per mole. The standard electrode potential for the Daniell cell is 1.1. Calculate the Gibbs free energy for the reaction. The same thing. Same question has been in a different way. Standard electrode potential for the Daniell cell is given. Calculate the del reaction. Here they had given the equation. Here they didn't give the equation. So Daniell cell itself, you have to understand the reaction between zinc and copper, right? Even though the equation is not given here, you have to find out and you have to do the work. Next thing, a zinc rod is dipped in 0.1 solution of zinc sulfate. The concentration is 0.1. The salt is 95% dissociated, and at this dilution at 298 Kelvin, calculate the E naught cell. Calculate the standard electrode potential. They are asking electrode potential, not standard. So they are asking for the E cell. So E naught cell value they had given minus 0.76 they had given, and they had given the concentration they had given, and the salt has been 95% dissociated. The electrode reaction, it has been not given in the equation. So by using this, we have to write the electrode reaction. Zn gives Zn plus 2 electron gives Zn. So the number of electrons involved is 2. So now we have to apply the Nernst equation. So what happens here? The zinc has been gone to Zn2 plus has been gone to Zn. So reduction. In the case of reduction, the Nernst equation is E cell is equal to E naught cell minus 0.0591 by 2 log of 1 by concentration of M12 plus we get C. That is the ion of the reactant. Right. So here Zn2 plus 1 by Zn2 plus. The E naught cell value they had already given in the equation, right? E naught cell value we have to substitute minus 0.76 and they had given 0.1 zinc sulfate solution and it is 95% dissociated. So Zn2 plus is equal to 95 by 100 into 0.1 that is equal to the concentration of the solution. So 95% dissociated out of 100, 95% dissociated that is 0.1 solution. So we can get the concentration of the solution 0.095, right? So that is a concentration of here. This should be in the square bracket. This should be in the square bracket because it is a concentration term. Na? So instead of this Zn2 plus, we are inserting the concentration term here. So that will be minus 0.76. If we simplify these two terms, if we simplify these two terms, we can get minus 0.02955 into log of 1000 minus log of 95. So we can get 3 minus log, we are taking log of 1000 is 3, log of 95 is 1.9777. So we can get 3 minus 1.9777. So minus 0.76 minus 0.0295 and this value we can get the value minus 0.79021. Right, this is the final value. Again, I'm coming from the beginning. Let us go for the question here. A zinc rod is dipped in 0.1 solution of zinc sulfate. The salt is 95% dissociated at 298. So they had not given the concentration of zinc ion directly. They had given the concentration as 0.1 and is 95% dissociated. So we have to calculate the concentration of the zinc ion here. That is the calculation here. Here this part. That is 0.1 of zinc sulfate solution is 95% dissociated. So this means that 95 by 100 into 0.1 that is equal to 0.095. This is a concentration we have to work on, right? And then calculate the electrode potential. E cell they are asking, they had given the E naught cell. Upon we have to use a formula. E cell is equal to E cell is Zn2 plus minus E naught cell. E naught cell value they had given 0.051 by 2 number of electrons involved log of 1 by concentration of the zinc here. Concentration of the zinc we get find out, so we get substituted here, right? By simplifying the things we can get the answer 0.79021 volt, right? Okay, next question. Calculate the EMF for the cell given at 25 degrees Celsius, right? That is 295, 298. Yeah, I missed one question. Here it is 298. Here it is 25. Oh, let us go for this question first and then we can come here. Determine the value of equilibrium constant. They're asking Kc and del G gives free energy for the following reactions. They are given E naught cell value. E naught is equal to 1.05. So we have to find out del G as well as Kc, right, for this reaction. So the number of electrons involved here is 2 electrons, right? Ag2 plus Na2 plus 2 electrons involved here. Here, log Kc is equal to N of E naught cell by 0.0591. This is a formula to be used here. So to calculate the log Kc here. So N, the number of electrons involved with 2. E naught cell value they had given us 1.05 volt. So if you are substituting that, log Kc is equal to 2 into 1.05 by 0.059. That is equal to 35.5932. Right. So this equation log Kc is equal to N of E naught cell by 0.59. This comes from this equation. E naught cell is equal to 0.0591 by log Kc. Now we are keeping the log Kc here and we are shifting everything to here. So that will be n will go there, n E naught cell, and this will come under the division, right? So E naught cell, n of E naught cell by 0.0591, that is equal to log Kc. So this is log Kc we get taken here. So for Kc we have to take anti-log. This is log Kc is equal to 35.5932. So Kc is equal to anti-log of 39.5932, or Kc is equal to 3.92 10 to the power of 35. Now we have to relate, we can find out the Kc. Now we have to find out the del G naught. So del G naught is equal to minus NAP cell, direct formula. The number of electrons is 2, Faraday they get given, E naught cell value they get given. So del G is equal to, if you substitute this in this equation, we can get 202.65 kilojoule. Always express the things in kilojoule, right? Kilojoules means nothing but you have to divide it by 1000. Joules divided by 1000, right?